Everyone. So we're going to talk about area of a right triangle. To begin with, let's make a right triangle. As always, pigeon poo. Nick, come on, man.
Come on, I don't have any people.
We all have pigeon poo. All right, so if you can't find one, make one. So let's make a right triangle and give this an H for height, whatever. Um, so this all works out. As we did in the old days, we can call this little b. Um, as we did in the old days, we could say that the area of this triangle, area of the right triangle, equals what? Think old school. Base times height divided by 2, or some people say 1/2 base times height. And that's very cool. Okay? Nice. Now, let's talk about this in terms of sine and cosine, things like that. We can call this little c here, can we not? We can, because we have big C way over here, right? So the idea is we want to eventually take these trainer wheels off that are H and be able to just deal with this triangle without the H. In other words, this part here is gone, and try to figure out a way that we can express it that way. Okay? So right now we've got H and we want to try to get rid of H. So the best method usually when we do something like that is to solve for H. Okay? So right now we have that area of the right triangle equals 1/2 base times height. So Nick, what would H equal in this deal?
Um, the tiny c square. Actually, um, sine of
Okay, I like that. I like where you're going with this. So you could say sine of A equals what?
equals
Sure could tell. Good. He dug that one out.
h over c.
Nice. H over C, which is the length of this opposite side from A. And I cannot stress enough, it's from A, that's opposite, and that's hypotenuse. If we were talking about B, then the opposite would be down here. But in this case, it's H over C. Okay? That's all right? Okay? That's good. Now, then what would H equal? Or, let's try to solve for H. Get rid of that variable if we can. All right. So what could we do? Zane, you got a thought? Multiply by C. I'm good with that. Multiply by C, both sides, and then we get C times sine A equals H. Beautiful. Now, again, let's think back to when we said 1/2 base times height, right? Right? So now we can say that's H. Okay? So that H, it gets even better. That H applies for this whole triangle here. Yeah? That H represents the height. That C sine A represents the height of this whole entire triangle. It's beautiful. Lovely. Yeah? So, now let's get that back. I'm going to try to just drag this down. This is great. Now, help me remember what I labeled things, though. This is A, this was C, this was big B, this was little b, this was little c, and this is little a, right? And we actually know the height of that in secret, right? We know the height is C sine A. So, let's think about what's the area of this triangle if we know this angle here. That's a known quantity. Well, we can say the area of the triangle equals, base times height divided by 2 or times 1/2. Yeah? So now let's put in place what Nick shared with us. Instead of, the 1/2 stays the same. We got that. The base we said was what? The base is this guy right here. B, thank you. Man, was that you, Mandy? Thank you. Wow. 1/2 B times. Now, what did we say in place of H? We'll call this the Nick theorem. C sine A. And that is brilliant. Notice that works for any triangle, anytime, as long as you know. And I'm going to say, note that angle A is included, and this is really an important term, included between sides C and B. Okay, so this is really important. You got to think, what was it, Kramer? Sassy. You got to think sassy. Side, angle, side. It has to be included. It has to be sandwiched in between C and B. Vital. Vital. You got to have it. Okay? And then did we talk about the other versions of this yesterday? For instance, if you know C. Did we talk about that? I guess not, based on your responses. We can say, or, Miss G, back for more papel.
Yes.
Thanks. Okay, or we can say, and again, you know what? The book is kind of smart. They say K here for area, and that probably is good. Or we can say K equals 1/2. Now, what if I know, Sean? What if I know side C here? I'm sorry, angle C. Man, I'm a mess today. What if I know angle C down here, big C, and A and B? Right, what would it look like though, Sean? One half AB sine C. Good, Sean. That was excellent. Or, give me another or. What would the last one be? Who haven't I picked on? Alexis, how are you? Yeah. What would the other one be? K equals, and now we're talking, the only one left, we would know B, angle B, and we would know side C and side A. What would we have there? Lexus, I'm sorry, that machine was going by. Max, will you shut the door, please? I'm tethered. Alexis, what do you have? Yeah. We know angle B, the big B, and we know side C and side A. Yeah, and most people go AC, sine B. And so all of these work. All of these work, okay? If you know, and I really don't memorize all of these ever. All I think is, if I know an angle and the two sides, that Kramer rule, side, angle, side, SAS. If I know that two sides included angle, I can just go 1/2 this times the sine of this. I'm good to go. If I know these guys and it's included, I can go 1/2 this times the sine of that. And I'm good to go. Okay? Questions on that? Questions on that? I hope that you guys had that last year. Maybe not. Okay, I'm going to throw one last thing on because it's such a beautiful extension of this. Okay, so lovely. It's lovely, lovely, lovely. So let's lay these out in order. I wonder if I can get them. I wonder if I can capture them. Okay, group. Okay, there's one. No. Yes. All right, stay with it. Don't lose it. Clone. Okay, so here we go. Tanner, you're going to be up. So get the brain ready to roll. Okay? It's going to happen here shortly. So I got that. Can I get this? Almost. Almost. I wanted to grab these and just bring them down and show you where I was getting them. Boy, that is a bummer. Okay, I got to write it. Equals 1/2 AC sine B equals 1/2 AB sine C. Okay, Tanner, you ready? Okay, good. Now, we are going to try to clean this up. Okay, Tanner, what could I do? And you're not used to seeing 3 items, and that's okay. What could I do to clean this whole thing up? Well, we're going to do that later, but not yet. Now we've got to honor all 3 of them. Okay? Yeah, there are common terms. There's a 1/2 and a 1/2 and a 1/2. What could we do to those to clean things up? Divide them out, which works. Same as multiplying by a reciprocal, which in this case is 2/1. Perfect. So I'm going to multiply everything by 2/1. And then what do I have left? BC sine A equals AC sine B. Nice job, by the way, Tanner. Good recovery. AB sine C. All right, now, let's work some more to clean this mess up. Oh, man. Maddie, how are you? Okay, now, if you just consider these two, what could you do to clean them up? They both have C's. They do. So you could say, divide that by C, divide that by C. But knowing that they're all equal, this side over here is going to get jealous, and you're going to have to divide it by C as well. Okay? Now, Zachary, how are you? If you look at just these two, let's go this way. Look at this one here and this one here on the outside. What do they both have? Well, do you see anything, a common term? Tanner hit it on the head. Do you see a common term here and a common term here that are the same? They do, but this is sine C and this is sine A, so we cannot call that common. They both have a B, exactly. And thank you for saying I don't know, even though you felt like it. You know, thank you for not saying I don't know, even though you felt like it. That's what I meant. Right. So we're going to divide by B. We're going to divide by B. But then, look, it's the middle child, Courtney, right? And they're always volatile and jealous and, right? Kramer? Well, whatever I do to one side of the equation, I have to do to the other side of the equation. And because I saw a C here and a C here, which was correct, and I divided those by C, I have to divide this third one by C as well. And I have to do that volatile, angry middle child by B as well. Have to. Well, let's see what happens. Let's see what happens. We forgot about A. So, Mandy, you're on the clock. What do we do here then? There's an A in both, right? Divide A out. Thank you for saying that beautifully. And whatever we do there, we got to do here. So let's start dividing these guys out like crazy. C divided by C is?
1.
B divided by B is? A divided by A. 1. C divided by C. It's getting old. It's getting boring. But those are all ones. And that's cool. And what we have left, and I know you've seen this before, it's nothing new. Sine A over A equals sine B over B equals sine C over C. And that's right. Law of sines. Very, very, very useful. Oh, I'm here to tell you. Right, and that's important. At this point, right. Yeah, I knew what you meant, Nick. Okay, so we've got law of sines. Now, the one thing that people do wrong on this all the time is they try to use all three. And I'm going to say note, only use 2 at a time. And we're going to do just a really, really quick. We're 16 minutes into this video. We're going to do it really quick. Okay? So, I need a shape recognition pen. I need a little triangle of some form. I need, how many degrees is this one? 30? Sure. 30 degrees. And we'll call this side M. And what's this one up here, Ty? Oh, that's bigger than 60. Come on, Ty. 100. Thanks, Ty. Good job. Okay, and then we'll call this 15 meters, let's say. All right? Now, notice, with the law of sines, I know, but it doesn't matter. We don't even need it. You need 2 angles and 1 opposite side, or 2 sides, you guessed it, and what? And 1 opposite, no, not included, and 1 opposite angle. Okay, so this is a situation where you use law of sines. Okay, so what do we have? We have 2 angles and 1 opposite side. We're good to go. Okay, this will work. Heck, I'm gonna move this over. I'm gonna get wild. Go ahead, Ty. Don't let me move. Okay, here we go. So we can say that the sine of 100 degrees over 15 meters equals the sine of 30 degrees over what? M. Some letter M. And I'll put it capital here just to make it look a little bit better. So you don't confuse that with meters. So it's M meters. Notice how I only use 2 of these. Okay? I only use 2. A lot of people try to use all 3, and you don't need 3. You only need 2 parts, and it doesn't matter which parts you use, and then it works. Okay, Courtney, what would be the next step? I would cross multiply. Because it's a proportion. Whenever you see one fraction equal to another, it's a proportion. I'd cross multiply and divide. We can just cross multiply first, though. I'd go sine 100 times m equals sine 30 times 15. Somebody jam that for me. I don't like that. All right. Mandy, what'd you get when you did that? So go ahead and do that. So then M equals sine 30 times 15 divided by sine 100 equals, jam on that, 7.6 what? Okay, hang on. No. Nick, come on, man. If you're going to keep going, that's fine. But if this is the final answer we're looking for, 7.6 is fine. Because remember, this distance was given to the nearest meter. So let's give it to the nearest tenth of a meter and call it good. Now, 7.6. Is that a reasonable answer? Well, we know that the longest side has to be which one? No, there is no hypotenuse because it's not a right triangle. You're okay. You're okay. The one opposite 100 degrees, that's the biggest angle. Therefore, the longest side has to be opposite it. 30 degrees, smallest angle, Nick? So this has to be the shortest side. So I think 7.6 is a reasonable answer. Okay? Questions? You have been a great audience. Thank you so much. This will be available online tonight if you want to watch it. Thank you all for listening.